Hello. So welcome to my class. Okay, so in last class we discussed distribution. Right? So distribution is just a table listed all cases. So like for this example, we wanted to give out the distribution for these things. So we need to use the table. Like, okay, so this x can be which numbers, and also we need to find its probabilities for taking those numbers, right? So here, let's say x is a number for ace card. So you just pick one card from 52 playing cards. So you can get one ace or zero ace, right? No ace. You can get you can get an ace card. So we denote this as one, and you cannot get you get other cards. You cannot get an ace. We denote this is zero. So you get a zero ace. So this x can be 1, 0, right? And the probability is if you can get an ace, so your probability is, I think, 52. Among 52, you have 4 ace. And then not ace, so 52, 48. So this is a distribution for x. Okay. So from a distribution, we can find an important number. So we call this number the expectation. So we call this number expectation in gambling or in probability. But this number in statistics, we call this as a mean. Okay, and we denote this as mu. The mean mu equal so E means expected Ex. So we say this expectation or mean, this E can stand for average. So from a distribution, we also can find variance of X. So variance, this word comes from vary. Okay. So we use this number to measure how much changement of this variable. So the definition for variance of Vx, variance for x is thus x minus mu square. So we can understand this as x minus mu square's average. Okay. So now let's consider this simple example. Suppose like x follow this distribution. We want to find its mean. We want to find its mean and variance. So this mean equal x. So the definition for x is just that x can take those numbers, x multiply the probability for taking those numbers. So 1 times 0.6 plus x can be -1 times 0.4. So this equal 0.2. Okay. So this is the mean, right? Then variance. So for variance, we also have a notation for variance. We call this a sigma square variance equal. So this sigma is a Greek letter, sigma. Okay, sigma. Okay, so Vx. So what is Vx? According to definitions, Vx is x minus mu square. Okay. So this x, so here we say mu is fixed, but this x can change. x can be 1 or -1. So this x minus mu square can be this square, like x1, so mu is 0.2, right? 0.2 square. Then multiply the probability that x equal 1. So this thing happen. So this thing happen is probability 0.6, right? And also this x can be -1. So x minus mu square can be -1 minus 0.2 square. Then multiply the probability is 0.4. So after a little bit of calculations, we can find this number. So we just use this number to measure the changement. We call this number the variance. Okay. So we have many distributions. So here we discuss some typical distribution. So simplicity distribution is called Bernoulli distribution or 1-0 distribution. Okay, so 1-0 distribution. So we have this distribution that x can be 1 or 0. So the probability for x taking 1 is p, and x taking 0 is q. So at the first, we know there's p plus q should be 1. Alright? Okay. So we can regard this as something happening or something not happening. If something happening, we denote this as 1, right? And not happening as 0. Just like we pick a car. If this is ace, we put this 1. If it is not ace, put a 0. We have 1 ace or 0 ace, right? So once we have this distribution, so we want to find mean and variance. So mean and variance of Bernoulli distribution. So we have this result. Mu equal p, and variance sigma square equal pq. So let's confirm this. So mu, this is easy. Mu equal x equals 1 times p, that's 1 times p plus 0 times q, right? So this equal p. Okay, so then what is variance? So sigma square, we say sigma square equal variance of x, and this variance, the definition is x minus mu square. Okay, so here x can be 1 or 0. Mu is fixed, equal p. So this is just x minus mu can be 1 minus p squared. Then multiply the probability for this thing happening is p, right? Then plus x can be 0. So 0 minus p squared. So multiply the probability for x taking 0 is q. Okay, so we find. So here we have we have pq. So their relationship is p plus q equal 1. So here 1 minus p actually is q. So that's equal q squared, right? Q squared p plus, so here 0 minus p, just p, p squared q. Okay. Okay, so we find, okay, so we can take a pq other side. Pq can take a pq other side. So this is q plus p. So q plus p or p plus q, you say equals 1, right? So that's equal pq. Okay. So this Bernoulli distribution is just like those situations. We try something, and something happen or not happen. Or if we try once, the number of success can be 1 or 0, right? So such distribution is Bernoulli distribution. So then, so let's consider. So how about if we try one time, or how about try many times? Try n times. Then what is the distribution if we try n times? So now let's consider this problem. Let's say okay. So in our first quiz, there is one question. So with 5 choices, A, B, C, D, E. So you pick your answer randomly. So we let X be the number of your correct answers. So this X, number of your correct answers, can be 1 or 0, right? The number X equal 1, you get a 1 correct or 0 correct. So try one time, you can get. So the probability, so X equal 1 means you answer correctly. So we have 5 choices. A, B, C, D, E. Right? So the probability you answer correctly, you pick a correct answer is 1 over 5. And then this is 4 over 5. Not correct is 4 over 5, right? So this distribution is 1-0 distribution. So this is, we call it the Bernoulli distribution. So now how about, we have 2 questions. Okay. And we let X, the same thing, that's the number of your correct answers. So this number, let's say, this number can be 0, right? You do not, both of them are not correct. And it can be 1, you get 1 question correct. Or can be 2, right? Then we just need to find the probability for those things happen. So X equals 0 means you answer first question wrongly. And the second question also wrongly. So first question wrong is 4 over 5. So second one is also 4 over 5. The first one is wrong. Second one also is wrong. So actually this is 4 over 5 square, right? So bad things happen 2 times. So what is the probability for X equal 2? So meaning X equal 2 means you answer both of them, you pick both of them correctly. So first one correctly is 1 over 5. And the second one is also 1 over 5, right? So we can put 1 over 5, 1 over 5 square. So then we can find what is the probability for X equal 1. You just get 1 question correctly. So for this question, for this probability, we can use this because this all the probability added together is 1. So such a probability X equal 1 equal 1 minus X equal 0, 1, and minus X equal 2, right? And also we can use the other way, like you get one question correctly, so can be like first one correctly, second one wrongly, or plus first one wrong, second one correct, right? So we can find it as a probability. So first one correctly is 1 over 5. Second one wrongly is 4 over 5, right? So plus, so first one not correctly is 4 over 5. Second one correctly is 1 over 5. So this actually, there's two things same. So we just put this equal like 25, 5 times 5, 25, 8. Okay. So we get this distribution, or if we just use common denominator O of 25, we can get this. So this is 25, 1. This is 25, 16. This is 25, 8. Right? Okay. So this is for if we have two questions, then this distribution become a little bit more complicated. So how about we have 10 questions? So 10 questions, we say those distribution, if we list this as such a table, this is not so good, because we have the number of your correct answer can be 0, can be 1, can be 9, can be 10. So too many cases. So for such a problem, we prefer use some other way. So let's consider general situation. Let's say general situation is we try n times. So each time you can get a success or not a success. Or each time good thing can happen or not happen. Just like for you pick your answer each question, you can pick a correct answer or not a correct answer, right? Good thing can happen or not happen. So if you try n time, we let x be the number of success. So this x can be 0, can be 1, can be 2, can be n. So if n is big, then we say too many cases. So there's a table. If we use a table for distribution, the table is too long. So here we know x can take those values. So we just focus on the probability for taking those values, right? Okay. So here we have this formula. X equal k is this formula. So once we have this formula, then we know the probability for x taking those values, right? So we just regard this formula as a distribution. And we don't need to use a table, right, to list all these cases. If we have the formula, then we know everything. So we just call such a formula as a distribution. And this distribution is called a binomial distribution. Okay. Okay. So now let's check why we have this formula. So we can consider like this. Let's say like we try n times. So first one, second one, third one, n time. Okay. So for each time, each trial, something can happen or not happen. right? So like here, can this thing happen? We use this thing happen, good thing happen, or this not happen, or good thing happen, like that, right? So x equal k means good thing happen k time. So this k time can be like this k time, like this k time, or can be like this k time, right? So here's no, 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 right? Okay. So for each case, the probability, let's say, good thing happens P. So bad thing happens Q. So here's P, here's Q, right? This is P, like that. So we just say that here P, good thing should happen K time. And then bad thing should happen remaining times. So totally we have n trials. So here Q should happen n minus K, right? Okay. So we say, so here we have many such cases that the good thing happen K time. K time can happen this K time, K times or that K times. So how many such ways? So this is just like from n positions, we just pick k positions. So like from n position, pick a k position. Say like from n positions, we just pick a k position. So how many such ways? So we know this equal n, from n choose k, right? Okay, so we know there's a probability x equal k equal, so from n choose k, from n times we just pick k times, and this k time good thing happen. So good thing happen k time, p happen k time, and then bad thing happen n minus k. Okay? So this is a binomial distribution. So a typical example for binomial distribution is just such a problem, right? If like in a quiz we have 10 questions, and suppose you just pick the answers randomly, you just do not study at all, so you just try your lucky. So whether you can get good grades or bad grades, so depends on whether you are lucky enough. Okay. So let's check this problem. Okay. So we have 10 questions, each one with 5 choices. So A, B, C, D, E, multiple choice question A, B, C, D, E. So this means you pick a correct answer is 1 over 5. So not correct is 4 over 5. So we just want to find this probability. What you can get 6 questions correctly. So just exact 6 questions correctly. So such a probability we can regard as. So this we know this binomial distribution, right? X equals 6. So among 10 questions, you get 6 questions correctly. So this probability from 10, pick 6, from 10 questions, pick 6 questions. For these 6 questions, you should answer them correctly. So correctly is 1 over 5. So each one correctly, so this thing happens 6 times, right? Then For other 4 questions, answer them not correctly. So not correctly is 4 or 5. There's a 4 or 5 happen 4 times. So this is just the answer. So usually we will give me this. This can be our final answer. We don't need to do evaluation. We don't need the numerical answers. Okay. Okay. So now let's check some other examples. So we have many things that follow binomial distribution. Like we try something many times. So this thing happen or not happen. So happen or not happen, we have 2 cases. So binomial, bi means 2, right? So now let's consider this problem. Like okay, so let's say for some product is so we purchased 100 of their product. So for each product can be good or not so good, right? So this is the defective rate. Defective rate is 3%. So this 3% is just a probability. A bad thing happening, we say such a thing happening 3%. Okay. So now let's say so we bought 100. So among these 100, so we want to find how many bad, how many not good or defective. So let's check this question. They are exactly 2 defective products. So here we can regard it like we just check all those 100 products. So this thing can happen, or bad thing happen, or this thing happen, or not happen. So this thing happen exactly 2 times. So such a probability is we just use among 100 products, we just pick 2 products. So these 2 are not so good, right? So not good. This probability, this thing happen is not good. This thing happens 3% or 0.03, right? This happen 2 times. And then for all other number 8 product, all are good. So good is number 7, right? 3% not so good, so number 7% good. So good happen number 8 times. Okay. Okay. So we can leave this as our final answer. So now let's say we want to find at least 2 defective product. So at least, so we let X be the number of defective product. So we want to find X at least like that, like at least 2. So can be 2, can be 3, can be 5, and can be 100. So this we can use this notation. This X larger than or equal to can be Px equal K. This K, K can be 2, can be 3, can be 5, until 100. Okay. So here we have many cases. Actually, we have 97 cases. So for such a probability, if we want to find such a probability, we can consider its opposite. So equal 1 minus x equals 0, not at least 2, right? X equals 0 and x equal 1. So what is those probability? So we can so at first we know those things are binomial distribution. So x equals 0. So bad thing happen 0 times. So good thing happen 100 times. So this good thing happens 97. 97, good thing happen 100 times, right? Okay. So x equal 1 means bad thing happen 1 time. So good thing happen 99 times. So this 1 can be like from 100, we just pick 1. So this one not so good. Not good is 0, 0, 3. And all other is good. 97, so 99. Okay. Okay, so those are binomial distribution. Okay. So we say for any distribution, we want to find mean and standard deviation and variance. So for binomial distribution, we also want to find mean and variance. But before we find those number mean or variance, let's check this problem. Let's say, suppose in our first quiz, we have 100 questions. So each one has 5 choices, right? So let x be the number of your correct answer. So this x can be 0, can be 1, can be 2, can be 100. So here we have the question. Which number is more likely? So we say x equals 0 means all are wrong. And x equals 100 is all are correct. So usually those ending points, those extreme situations should not happen. So we have those words like too bad, or too good to be true, or too bad to be true. So then, which one is most likely number? Which one is the most likely number? Or could it be like 10? So let's check those, like 10 or 20 or 30, 40. Like which those numbers, which one is more likely? So for this question, so we can check this, like, okay, each one has 5 choices. So A, B, C, D, E. So we have 5 choices. So this means you get a correct answer is P is 1 over 5. Right? So this 1 over 5 also means among 5 choices, you can get 1. Very likely like you can get 1. Okay? So we say like from 5, you can get 1. So now we have 100 questions. 100, you can get what? How many? So we find 100 just equal 20 times 5. So we find you can get 20, right? So this 20 is the most likely number. Like if we have 5 questions, most likely you can get 1. So if we have 100 questions, most likely you can get 20, right? So this 20, this number is important actually, right? So this 20 actually is just the mean. So we can say mean is most likely number, the mean. And so here we have the formula for mean and variance of binomial distributions. Mean is NP, and variance is NPQ. So for those formulas, we can regard binomial distribution just try n time. Like if we try one time, here try one time, or try one time. This is, we know mean is P, right? And variance is PQ. Then try n time, mean is NP. And variance just multiply NPQ. Okay? So this 20 is just NP. This 20, so we can say 20. How can we get a 20 is N 100? Try 100 times. And P 1/5. Right? Okay. So in statistics, we can explain this mean as the most likely number it can be, right? Okay. So now, suppose like suppose in our first exam or first quiz, we have 100 questions. So each with 5 choices. So let's check some probability problem. So you can get at least 2 questions correctly. At least 2 questions correctly. So we know this is, we just want to find this probability at least. So we can use this, like can check its opposite case. So equal 1 minus px less than 2, right? So less than 2 equal, so can be x equal 0, less than 2, or x equal 1. So x equals 0. So we know x equals 0 is, let's say that the x is number with correct answer. So number of the correct answer is 0, means good things happen 0 times. So bad thing happen. So bad thing 4 or 5. Bad thing happen 100 times. And here x equal 1. So this means you can get 1 question correctly. So corrected 1/5. This thing happen 1 time. And so here, which question you can answer correctly? So we just from 100 pick 1 question. Answer correctly. Then not correctly is 4/5. 99th part. Okay. So for this, the numerical answer for this is 4/5 is 100 power. Such a number maybe can calculate by calculate, or may not be able by calculate by calculate, because this number is too small. Our calculator maybe do not have enough space to save the number. Okay, but anyway, so we can regard such a problem we can solve. At least 2 questions can solve, because It's opposite side, only few cases. So how about this one? At least 40. So for such a problem, we say at least 40. We can say this, if we check opposite side, it's okay, equal 1 minus p x less than 40 or less than or equal 39, right? But here, less than or equal 39, we also have many cases. Like x can be 0, x can be 1, can be 2, can be 39. So for such a problem, we say both sides, we have many cases. So we use this formula, cannot simplify very much. So we have this question, how to find those probabilities. So sometimes we do need to do those things. Like suppose like in our exam, I say if you get at least 40 questions correctly, I let you pass the exam. So such a probability is just like this. The probability for passing the exam. So sometime maybe we wanted to calculate, we wanted to estimate, we want to have the numerical answers, or we wanted to know the percentage for this, right? What is the chance? How much is the chance I can pass the exam without any start? So we, in some real situations, we do need to do those calculation or find those probabilities. So how can we solve those kind of problems? So this will be the topic for next class. So we can stop here, and thank you. So see you next class.